Hello friends, very good morning to all of you. So today we are going to discuss PF45, that is Performance Tuning Guide. So yeah, you can easily download that document from Ping Identity website and just go through. You will able to understand what Ping Identity is suggesting in terms of tuning the things. But yeah, in this video I just want like few things to discuss so that you are aware of basically on threads part, on database thing, which is really going to help you in troubleshooting things. So we'll just talk about those things: JVM Hep size, some thread things, and yeah, I'll just upload that. I'll just give a link on the description so that you can download if you want to read the complete thing. But yeah, we just try to understand a few things that is very important. And yeah, let's begin so we can talk. Session will talk about the performance tuning guide. So if you can directly search in the internet on the in the browser, you can able to get that article. And for getting the detailed information, I'll recommend to go through that. I'll just show you in my I just put that in my repository also, but you can go through that and check it. But I just want to discuss few things which you need to know. For an example, if you haven't get a chance to read the complete tuning guide documentation, but yeah, in that case also you need you have some knowledge, the important part in that, which you can just utilize in your troubleshooting things, or in just making your environment more scalable, more like reliable. Okay, so let's go to the Ping repository section. So I just put this PingFederate performance tuning guide in this place. I'll share the link, or you can just directly search in the browser also, you can able to see. This is for the version 8.x. okay, so in this document you can see it's talk about more things, right? It's talk about, like, you can just have a look on this. Like, it's talk about logging, concurrency, right? Acceptor thread, server thread, data store, caveats, and you have the memory, JVM heap, additional JVM options, modifying and adding JVM commands line operation to PingFederate. So all these things is talking about, right? So I'm not going to discuss everything here in this session, but yeah, the main thing what I see it's important, and you need to know, and then only you can able to troubleshoot the problems if you just face the same thing. Because yeah, if you're just working in the on-premise environment, definitely you can have faced those problems, right? You maybe have seen those problems earlier also. Okay, so introduction is talking about the out-of-box configuration for PingFederate is acceptable for most small size deployments. However, for mission critical high transaction volume deployments, additional tuning is recommended. The fine tuning of your simple application and system level application will enable you to achieve maximum performance out of hardware chosen for your deployment. That's true. Okay, so logging, concurrency, acceptor thread pool, and all. Yeah, so let's quickly have a discussion on this. Yeah, so let's start the discussion with the topic here, like the concurrency, right? This is very important thing. Yeah, logging is fine, like log4j2, we have some knowledge on that, how we can just maybe you have seen in the previous session also, but we haven't talked about concurrency, right? We haven't talked about any acceptor thread or server thread, like those things. Yeah, so this topic is very important to discuss in this session. So concurrency means like when you have simultaneously you have more number of requests hitting to PingFederate. Like for an example, you have PingFederate running and you have like thousands of OAuth applications. So at the same time, maybe you have some peak hours, right, where people starting doing the job, right? So at the time you can see simultaneously you are getting more number of requests. So how PingFederate is handling those, right? So those things are important to understand in the session. So you can see it's talk about in most cases the more requests that are processed concurrently increases the number of requests that are processed overall. Given the appropriate amount of hardware, processing and request concurrently is typically faster than processing and request serially. Okay, so in PingFederate there are basically two main pools of thread that control the level of concurrent user request. One is called as acceptor threads, another is called as a server threads. So acceptor thread receives the HTTP or SSL request and pass those requests onto available server threads to be processed. Because yeah, one person has to receive the request and another person has to handle that request. So that's a concept of acceptor thread and the server threads. Now you can see here like acceptor thread pool. So by default the runtime SSL port 9031 that we are using by default in PingFederate engine is configured to run two acceptor thread processing a request queue that can hold a maximum of 512 connection requests. Okay, the acceptor threads pass the request to a number of non-blocking in I by O selectors, that is by default 1 per CPU core, that reads the request. So non-blocking I by O, I think you have understand this architecture, right? We discussed already in the past. So it's basically not depends on another process. Like if it is blocking architecture, that means it will stop. Like if it will just stop to complete the another process, then it will start doing the process. So if there are two processes, so the second process will stop to complete the first process, and then it will start. But the non-blocking is not like that. It's start doing the things, and in the simultaneously other process is also running, right? So that's a non-blocking we have already discussed in one of the session also in the past. So that's having, so basically here PingFed is by default is saying that it's configured to run two acceptor threads that processing a request queue that can hold a maximum of 512 connection request. Okay, and the acceptor threads pass the request to a number of non-blocking I by O selectors, that is by default 1 per CPU core, that reads the request. For optimal performance, particularly in larger deployments, we recommend switching to a purely non-blocking I by O model. Yeah, that's definitely required. If you're not going for the non-blocking in the bigger, larger environment, you can see you have more number of requests at the same time. So it will just all the requests will be in a queue. It will stop. It will wait for another request to complete, and in that case, maybe it looks your server is hung, right? Because it's not responding. It's not responding properly at the given amount of time, right? So definitely it's required as a non-blocking I by O model for the larger deployment. For a smaller deployment where we have very less number of users, then it's fine. You can work with the blocking I by O model also. Okay, now here tuning the acceptor thread pool. So how you can tune this? So first you just need to shut down the PingFederate if it is running. Then you can just edit the file of jetty runtime .xml. Okay, where like you can see this in the PingFederate etc. So jetty runtime.xml file has to be editable. So what we need to edit here, so you can see here like in the section of this you have acceptors, here it's mentioned as a 2, and here you have the selectors, right? Now if you can see, like scroll down, to switch to purely non-blocking I by O model, disabling acceptor threads by changing the value of acceptor entry to 0. Okay, set the value of selectors to 1. So in this case, like if you want to switch to purely to the non-blocking I by O, you just need to disable the acceptor threads by changing the value of the acceptor entry to 0. Okay, so we are not putting as a 2, 3 anything, just let's put it to 0 and set the value of selectors to 1. Okay, so if you can see here, right, acceptors value and selectors value. Okay, now if the queue reaches its maximum size, additional request will receive a connection refuse error. If this occurs in your environment, you can increase the value of the accept queue size attribute. Yeah, so if the queue reaches its maximum size, right, so if you put a maximum size of the queue will be like 100, and you can see it, if it reaches the that size, right, then what happened, if any another request will come at the same time, then PingFederate will give an error like connection refused. So if it's occurring in your environment also, you can increase the value of the accept queue size attribute. Okay, so you have accept queue size attribute as a 512, so you can able to increase that. Okay, this is about acceptor threads. Now let's look on the server thread pool. So the number of concurrent requests that PingFederate is capable of processing is controlled by the server container server thread pool configuration. When an HTTPS request is received, an acceptor thread picks an idle server thread from the pool and dispatches it to process the request. Correct? Now the default configuration defines a minimum of 15 concurrent threads with 50 for the low and the maximum number of threads. Okay, like 50 to maximum. This means that initially the server creates 15 threads for the pool. If that limit is exceeded, it generates up to 50 threads. So here, like the default configuration defines a minimum of 15 concurrent threads with 50 for the low and maximum number of threads. This means that initially the server creates 15 threads for the pool. If that limit is exceeded, it generates up to 50 threads. The configuration effectively limits the total concurrency of the server to a maximum of 50 requests. If all the threads in the pool are processing, additional request accumulate in the acceptor queue and wait until a free server thread is available from the pool. That's true, right? So if you have the maximum 50 threads only allowed, and if that is reached out, okay, that if it is like achieved 50, and in the same time if any additional request is coming, then it should be accumulated in the acceptor queue only, that means acceptor thread only, and it will wait until a free server thread is available from the pool. So once that, maybe if you have a maximum 50, and if that 50 is like is completed, it has to wait in the acceptor thread at request, and then once that server thread pool become clear by just processing the some request, then like acceptor thread will just send that request to the server thread to process. So this is a concept of acceptor and server thread, and this is very important, right? I'll just show you where you can see these configurations in PingFederate, like where you have just done the database configuration, where you did the data store LDAP data store configuration. We can see, okay, I'll just show you. Then you have the tuning the server thread pool. Okay, so what tuning required for the server thread pool? So when tuning the server thread pool, it is best to size the system based on the expected user load, setting the minimum number of threads to between 75% and 100% of the number of requests you expect the system to handle of most often. So if you have, like, if you see that 100 request is you are getting, so you can just set as per that, like you can see it's mentioning setting the minimum number of threads to between 75 and 100% of the total number of requests you expect. So you expect like 100 requests, so you can set that as a or you can expect like a 75 request, right? So you can just set as that as a 100%, right? So setting the minimum number of threads to between somewhere between 75% and 100% of the total number of requests you expect. So if you expect like 200 requests at the time, so you can expect the minimum number of threads to between somewhere 75 and 100% of the total number of requests. Set the maximum to between 25% and 50% higher than the minimum to handle load spike. And whatever you set as a minimum, just you can increase that to 25, between somewhere 25% and 50%. You can set that so that it can just handle the spike, right? For example, if you have a more number of requests came sometime, right, if an application team is doing some test in those situations, right? So mean you can just set as somewhere 75% or between 75% and 100% of the total number of requests you expect, and the maximum you can put as a just increase the minimum to between somewhere 25% and 50%. Okay, testing has shown that PingFederate performs quite well when the server thread pool is sized between 25 and 50 server threads per available CPU core. So if you are just using 2 CPU core, so you can just take as a like 50 and 100, like that. If you have 1 CPU core, like 25 and 50. If you have 8 CPU core, it depends, like that, 200 to 400, like that. So PingFederate just perform well in that scenario, right? So assuming sufficient memory, you can just see the memory section also. Note that this is the guidance and should not necessarily be scaled directly on the larger system. For example, if you're running PingFederate on a system that is with 24 CPU cores, it doesn't make sense to size the thread pool at a minimum of 600 threads and a maximum of 1200 threads. Okay, unless you expect to normal handle at least 800. So they have given some formula like 25 and 50 for one per available CPU core, like for one CPU core. So it's not like if you have 24 CPU core in your system, in your infra, you can just put as a mean as a 600 and max as a 1200 server threads, because you just need to see that like how it's handling, right? So you just need to expect, like it's mentioned, unless you expect to normally handle at least 800 concurrent requests. So you just need to see those things, right? So if you're working in the environment, you can able to understand that how much request I'm getting, or maybe you have some like monitoring tools, or you can just create some kind of shell script to get those data to understand, right? So for this, what you need to do, just click on shutdown if PingFed is running, go to the gtruntime.xml, right? And then you can see there is an option of thread pool, like mean threads, max threads, detailed dump. So you can just enable as per the configuration of your CPU core, right? And then you have modified using the following guidance: set mean threads to available CPU cores, max threads to available CPU cores, like 25 and 50 it's mentioned. So so mean threads, if you're putting whatever, it's just like the mean threads will become like that by multiplication of that CPU core. Okay, for example, if your PingFed system has one CPU with 4 cores, the total available CPU by core is 4. The configuration would be like mean thread will be 100. Correct. If you have the like if you are using the one CPU with 4 cores, that means you have the 4 thing, and then you are putting a minimum threads as a you're just putting mean threads to available CPU cores into 25. So you have the available CPU core is 4, so it will be 100. So mean threads will be 100. Yeah. So this is the thing. Then you have max threads, mean threads, and max threads will be 200. Like if you have the CPU core like 4. Yeah. Your system have the one CPU with 4 cores like that in this case. Yeah. Here we are talking for 24 CPU cores. Okay. In generally, like in companies like having larger environment, they're just preferring to use 6 or 8 CPU cores. Yeah. I don't see that people are using 24, but yeah, it depends on the infra to infra. If you have the very big infra, you can use that. And then you have the data stores, right? The LDAP and JTPC data stores use connection pooling to improve the performance and efficiency of communicating with external system. I'll just show you where you can see the thread configuration like here. Okay. And definitely one thing, like before doing any configuration, you just need to understand your environment first. Like it's not like maybe you have just read somewhere in the article, you just make a note and just you are doing the same thing, because it's not a theoretical things, right? It's a practical thing. So you just need to first analyze your own environment, like how many requests I'm getting, what is the peak time I'm getting, if some application to me is doing any test, then what is the number of concurrent requests I'm getting, and based on that you can take some decision and make the changes and do some testing like that. Okay, so yeah, this is for LDAP and database thing. Like you have the caveats. Yeah, it's mentioned, right? It is important to note that it's not a magic formula, but rather guidance for optimizing the concurrency of your PingFederate deployment. On a large multi-core system, a thread pool that is too small with underutilized available process or resources, a thread pool that is too large can cause the system to become flooded and unusable. So in both the cases, it's a harm. So if you have very like thread pool is very small, then again like your processor will just take more time, and yeah, the response will take more, and it will just degrade the environment. And if your thread pool is too large, in that case also it will just degrade your system, because what happened that if your thread pool is too large, the operating system will just need to adjust in that way. So yeah, it just need to handle that amount of thread pool. So yeah, it definitely, as mentioned, a thread pool, if it is too large, can cause the system to become flooded and unusable. Yeah. So based on that, you just need to. That's why I just told you, just analyze your first environment. It's not you can just put like 10 CPU cores, increase the thread pool size as mean and max to high, so that it cannot cause any issue. So it's not like it can cause issue in that case also, because unnecessary you are just giving that much memory, so the OS will just take that much time. Okay, so it's mentioned here, right? You can see here the good target for the CPU is between 60 and 80% utilization when under nominal user load. This way the CPU resources are not underutilized while still allowing room for occasional load spikes. The level of concurrency in PingFederate may need to be decreased depending on the system's configuration and available memory, as well as other processors competing for resources. All deployments are different. This would be serve as a guideline of where to start and maintaining the server. Then you have the memory. With increased concurrency comes an increase in the memory required, right? Moreover, PingFed is a Java application, and although this document is not considered to be guide to a garbage collection theory or economy like that, so PingFederate will automatically set many of its own memory setting based on the memory that is currently available on the system, not the total memory of the system. Okay, so what it says here, after the CPU, memory is the most important resource in your deployment. That is true. So in the previous section, we looked at how to configure PingFederate to support more concurrent requests. With increased concurrency comes an increase in the memory required. Moreover, PingFederate is a Java application, as we know, and although this document is not considered as a guide for the garbage collection theory or economics considered must be given to tuning that effects. Okay, so PingFederate basically automatically just adjusts, right? Set it's how much memory I need to run this. Yeah? So it can just take that, not the total memory of the system. And then you have the JVM Heap, right? So probably the most important tuning we can apply to the JVM Java virtual machine is to configure how much heap memory to use. If the demands of PingFederate require more memory than is currently available, the JVM must grow the heap or perform garbage collection to provide memory to allocate. Resizing the heap and garbage collecting can be expensive process and thus detrimental to performance. Okay, and the sizing the heap to ensure an adequate amount of memory is available but is still manageable, and to garbage collection is important in optimizing overall performance. By default, PingFederate launch script set the size of the Java heap based on the amount of free memory detected at a startup time, right? So when PingFederate started, it just detect that, yeah, what is the free memory, and based on that, it can just use the heap size of the heap based on the amount of memory detected at the startup time. In the case of Windows service, heap size configuration is set based on the amount of free memory available when the service is installed. If it's less than 2 GB is free, then heap is set to minimum of 256 MB, growing to a maximum of 1 GB. This means that when PingFed is launched, 256 MB are available for newly created objects. And if more than 256 MB are required, then the JVM garbage collects and if necessary, expand the heap until it reaches 1 GB. At this point, the JVM must invoke garbage collection in order to free up released memory to be reused. If at least 2 GB of free memory is detected, the Java heap is set to 1.5 GB. Yeah, and if 2.5 GB or more or free memory is detected, then Java heap is set to 2 GB. So yeah, basically it can just a second. Sorry, yeah. So that's the basically thing for the JVM heap. So yeah, so you can just define that in the, you can just tune that also, but yeah, it's very important. Otherwise, yeah, your performance of the PingFed will degrade again if that is not properly handled, because that is important to run this JVM Java virtual machine. Okay. So you can just tune this also, like to specify the initial size of the JVM, use the minimum heap variable, and to specify the maximum, use the maximum heap variable. And then you just need to go to PingFed server bin, and then for the Windows run.bat, and for the Linux is run.sh file, and then you can just adjust based on your infrastructure and the memory management of your PingFederate where you just deployed. Adjusting the heap size is what I stated previously. The JVM can grow the heap from the value of the minimum to the maximum heap variable. Growing the heap, however, that has expense to it. Requesting memory from the operating system is not an entirely expensive exercise. Plus, the JVM must now reorganize the heap to account for the memory being added. If conserving memory in your deployment is important, then setting a lower value for the minimum heap than that of a maximum heap ensures that you are not reserving memory that you are not specifying using. If, however, you have enough memory such that a certain amount is easily earmarked for the PingFed server, we recommend that you adjust the size of the heap by setting minimum and max to the same value. This allows the JVM to reserve its entire heap and decrease the amount of resizing that JVM needs to perform if the amount of memory being used exceeds the value of minimum, right? So you can just put minimum and max as the same thing. Okay, and then you have the young generation bias. Okay, so so you have additional JVM option is also there. If the JVM comes with a wide variety of tuning option, although the virtual machine should configure itself to run the base, it can, in most situations, it's sometimes advantage to run a specific application. In August, it's recommended that you test these options. Yeah, definitely. Yeah, whenever we are making some changes on the environment, we just need to ensure that how it runs. That's why you're not supposed to go for the tuning at the beginning, right? Once you for an example, you just deploy some environment with whatever the system configuration with the heap size, with the with the thread pool configuration, with the memory management, CPU, everything, right? You have done. So now just try to analyze that for some time to see how things are running, and then based on that we can take some decision and just adjust tune the things, whether it's a connection threads, whether it's a heap memory, whether it's a CPU or anything else, right? Okay, yeah, so this is about this. So yeah, mainly I just want to discuss about the thread thing, Acceptor Thread, and the server thread. because it is more important. Like I'll just discuss again on detailed part, like once we are going to cover the deadlock state, like how PingFederate, like in my previous project I have seen that like PingFederate is going in a deadlock state, and it basically hung the service completely, and now the users are just trying and trying, and their all requests are in a queue. It's not getting performed, right? So yeah, so I'll just discuss so you can understand more that part. And let me show you that what I'm talking to, in the connection thread option. Just go to system, go to data store. I'll show you in both the places. Now just open the like database. This is the internal database of PingFederate. Open this, go to database config, and then go to advanced. So you can see here like advanced database option, minimum pool size 10, maximum pool size 100. This is blocking time and idle time. So minimum pool size is 10 and maximum pool size 100. So this is a connection pool request. So you have min as a 10 and max as a 100. It's by default is given, but yeah, you just need to analyze your environment, and based on that you can adjust this value so that it can able to handle the request simultaneously as a concurrent time, right? The concurrent, it can able to handle the concurrent request, I can say. Okay. And this is going to play a role where in the case of like your OAuth and OpenID Connect based application, not like for a SAML, because for SAML applications, yeah, this database is not going to do anything. In our case, I'm saying in this environment, but yeah, in your environment, how you're doing the configuration, it depends, like whether you're using any external database or you're using ping directory, whatever you're using. So based on that, you just need to do the configuration there also. And if I can show you the LDAP also, let's open OpenDJ, go to LDAP configuration, go to advanced, and here you can see this minimum connections, max connections, and all the information you have here, right? Okay, manage LDAP connection pooling settings for the selected data store. PingFederate manage both a bind and a search pool for every LDAP data source instance. Okay, the settings on the page are applied to both connections pools separately. Okay, that min and max. Okay, and like yeah, blind and search pool. Okay, so this is about this configuration. So yeah, I hope you understand at least like on the acceptor thread and the server thread and the concurrent part. And again, we can discuss like when we discuss on the deadlock state, that yeah, how we can do some adjustment. And you can see like when you're just troubleshooting things, now you're able to understand, like because that's why I mentioned, right? So when you're making the design, when you're doing the when you're just putting a design of your environment, right? Like I have this environment, I know this number of users. Based on that, I put some memory here, I just put some memory here, right? So I've designed the complete thing. So let that design to be deployed, and then later just analyze like after some time, like after 2 or 3 months, 4 months, like how the things are running, right? See, like because, and for that you just need to have some more visualization. You can use Elk tool, you can use Splunk, you can use a kind of different monitoring tools, and then do some analysis, and that is very, very important. And I think it's happening in the industry also. Okay, so yeah, if you have anything, please put in the comment section, and we can quickly jump to the next section. Yeah, thank you.